So in this question here, I've got a parametric curve and I've got a circle. The circle here, which is labelled as C2, that one is x squared plus y squared equals 66. That's the formula for that. And the parametric curve, where t is from 0 to 2 pi, as x coordinate is 10 cosine t, and the y coordinate is 4 root 2 sine t. Now we want to find the points where C1 and C2 meet. So I've labelled them up S1 to S4 on these coordinates here, and we need to go back trying to find where that is. So we've got the circle equation is x squared plus y squared equals 66. Now we can use that to find the meeting points by plugging in the points on the parametric curve, which are 10 cosine t and 4 root t, and substituting them in because they represent our x and our y coordinates. So for my x, I could put 10 cosine t squared, same as in here, so I'm going to do that. 10 cosine t squared. And then for y, 4 root t sine t squared. So 4 root 2 sine t squared, and that equals 66. Right, so let's get rid of the brackets. So now I've got 100 cosine squared t plus square 4 root 2, 4 fours are 16, root 2 is just 2, so that gives me 32 sine squared t, that equals 66. Okay, now I've got cosine squared and sine squared, so I need to get rid of one of those trigonometric functions, so I've got the same function in there. So we know that cosine squared t plus sine squared t equals 1. So now I can get cosine on its own. So I'll have cosine squared t is 1 minus sine squared t. And then if I substitute that in for the cosine, I'll have both in terms of sine. So 100 times 1 minus sine squared t plus 32 sine squared t equals 66. Okay, right, now let's multiply out inside the brackets. So 100 minus 100 sine squared t plus 32 sine squared t equals 66. Okay, right, let's get the sine squared terms together. So that gives me minus 68. So I can write that in there for that. And if I subtract 100 from both sides, I get this 100 over here, and that becomes minus 34. Okay, right, isolate sine squared t, divide by minus 68. So therefore now I get sine squared t equals 1/2. So now take the square root of both sides. Sine of t equals 1 over root 2. So not forgetting the plus or minus. Okay, so that's what my sine t is. So now let's have a look, see if we can find out what cosine t is. So what we can do now, we've got cosine squared t translated to 1 minus sine squared t. So this time I'm going to get sine squared t in terms of cosine. So now I can have sine squared t equals 1 minus cosine squared t. So that will work isolating this sine squared, bring the cosine squared on this side. So now let's substitute that in for the sine. So now I've got 100 cosine squared t plus 32 times 1 minus cosine squared t equals 66. And as we did before, multiply out the brackets. So 100 cosine squared t plus 32 minus 32 cosine squared t equals 66. Okay, let's get the cosine squared terms on their own. So that'll give me 68 cosine squared t. 66 minus 32 gives me 34. So as we did before, let's divide both sides by 68. So now I get cosine squared t equals a half, and very similar result to before, cosine of t, square root both sides, so square root of this gives me plus or minus 1 over root 2. So that's cosine. Okay, so we've got sine t and cosine t. Now we know our coordinates here are the x and the y. So x equals 10 cosine t. So then we need to multiply this by 10. So therefore x equals 10 times plus or minus 1 over root 2. Okay, so now simplify this off. I'll have plus or minus 10 over root 2. So let's multiply the top and bottom by root 2. So then that will give me 10 root 2 over 2, which will give me 5 root 2. And then that's plus or minus. And now for the y coordinate, we've got 4 root 2 sine t. Sine of t is the same, plus or minus 1 over root 2. So now we need 4 root 2 times plus or minus 1 over root 2. Okay, so 4 root 2 times plus or minus 1 over root 2. These are just going to cancel. So that's just going to give me 4 plus or minus 4. So that's for my y coordinate. So that's our y. And then my x is this one here. Okay, so now we need to work out which corresponds to which on this diagram. Now sine and cosine are positive when all are positive here. Only the sine is positive here. Here is the tangent, that's positive, but sine and cosine here are both negative. And here I've got the cosine, which is the only one here, that's positive. Okay, so S1, let's find out what that is. Okay, so now I've got the results up here, all nice and tidy there. So now here they're all positive, so therefore S1, the coordinates for that one are 5 root 2 and 4. S2, here my sine value is positive, so that means my y is going to be positive, therefore my x will be negative. So now I'm going to have minus 5 root 2 comma 4. Okay, so that takes care of that. Now S3, so they're all negative in here. So now I'm going to have minus 5 root 2 and minus 4. And for S4, I'm going to have this one here where the cosine is positive, so my x is positive, so that's 5 root 2. And my y coordinate here, that's going to be the negative, so it's going to be minus 4 root minus 4. Okay, so that's the coordinates of the meeting points of curves C1 and C2. Okay.